Hello students, welcome back to my channel once again. How are you all students? Okay, so this video I am going to explain transport numbers from electrochemistry. Previous video or previous class I have taught Ostwald's dilution law. Those who have watched, those who have noted down well and good, but those who have not watched yet, please kindly watch the video students and kindly put all the points in your notebook and prepare for your exam. Okay, so let us start transport numbers, which is also a very important question from electrochemistry. What are transport numbers, students? We all know that conductivity of an electrolyte, it is equal to sum of conductivities of cation and anion. Okay, so an electrolyte on dissociation, we know that it produces positive and negative ions, nothing but cations and anions. So the conductivity of an electrolyte will be equal to, that means conductivity of cation plus conductivity of anion is equal to conductivity of the electrolyte. So the fraction or the amount of the current carried by cation is called as transport number of cation. Once again students, the fraction of current which is carried by cation. So whichever part of the current is carried by cation, that portion is called as transport number of cation, and it is denoted by Tc or T plus. Okay. Next, this Tc is given by lambda C by lambda C plus lambda A. What is this lambda C and what is this lambda A, students? Lambda C is current carried by cation and lambda A is current carried by anion. So Tc, that is transport number of cation. What is Tc, students? It is the fraction of current carried by cation. So how do we represent the fraction of current? Tc equals to lambda C by lambda C plus lambda A. Similarly, we can define transport number of anion. Fraction of current carried by anion is called as transport number of anion, and this is represented as or represented by Ta or T minus. Okay. So from Tc, so how you have written Tc? From that expression we can write Ta. So how will you write, students? From Tc will you be able to write? Tc equals to, you have written lambda C by lambda C plus lambda A. What will be Ta, students? Exactly. Ta will be equal to lambda A by lambda C plus lambda A. Here it is. Yes, Ta is equal to lambda A by lambda C plus lambda A. Now you know, students, this Tc plus Ta value will be always 1. Okay. So therefore, below I have mentioned a sentence, the total number of transport numbers of cation and anion is always 1. So we will try to show how this Tc plus Ta is equal to 1. Okay, students? Look here, students. Tc plus Ta is equal to 1. Okay. So now we know Tc equals to how much? Lambda C by lambda C plus lambda A, and Ta is equal to lambda A by lambda C plus lambda A. Okay. We will add these two. Tc plus Ta is equal to, write down, students, lambda C by lambda C plus lambda A plus lambda A by lambda C plus lambda A. Okay. Now this becomes Tc plus Ta is equal to, after adding these two, we get lambda C plus lambda A by lambda C plus lambda A. Okay. So both gets cancelled and the remaining will be 1. Therefore, Tc plus Ta is equal to 1. Okay. So that's what total number of transport numbers of cation and anion will be always 1. Okay. Till here understood, students? Adding Tc and Ta, we will get 1. But you know, students, this Tc, that is transport number of cation, is proportional to speed of the cation and Ta is proportional to speed of anion. Okay. So from this we can write like this. Tc by Ta is equal to speed of cation by speed of anion. So mark this as equation number 1, students. Okay. So from where did we get this? From this. Tc proportional to speed of cation. Ta is directly proportional to speed of anion. From this we can write Tc by Ta is equal to speed of cation by speed of anion. In turn, speed of cation is proportional to fall of concentration at anode. Again students, speed of cation. Here what did you learn? Tc proportional to speed of cation. In turn, speed of cation is proportional to fall of concentration. That means decrease in concentration at anode, and speed of anion will be proportional to decrease in concentration at this electrode, that is cathode. So from this you can write speed of cation by speed of anion is equal to fall in concentration at anode by fall in concentration at cathode. Okay. This is Tc by Ta is equal to speed of cation by speed of anion, and speed of cation by speed of anion is equal to fall in concentration at anode by fall in concentration at cathode. Mark it as equation number 2. From both the equations, combining equations 1 and 2, we get Tc by Ta is equal to Tc by Ta is equal to A by C. Okay. So where did we get this A by C? Here fall in concentration at anode, mention it as A. Fall in concentration at cathode, mention it as C. Okay. So Tc by Ta finally becomes equal to A by C. Fine students. Now Tc by 1 minus Tc. Where did we get this 1 minus Tc? Ta is equal to 1 minus Tc. This we are getting from Tc plus Ta is equal to 1. So from this Ta will be equals to 1 minus Tc. Okay. So in the place of Ta we have written 1 minus Tc. So Tc by 1 minus Tc is equal to A by C. Now cross multiplication students. C into Tc. Ctc is equal to A into 1 minus Tc. Now open up the brackets. A into 1 A minus A into Tc Atc. Now bring this minus Atc to left side. Left side what is there? Ctc is there. So Ctc plus Atc will be equals to A. Okay students. Now Tc, we can take Tc common out. So Tc into what is there inside? Now C plus A or A plus C. So Tc into A plus C is equal to A. Therefore Tc is equal to Tc is equal to A by A plus C. Put it in a box. Okay students, again shall I explain? Yes. Tc by Ta, from where? From equations and 1 and 2. Tc by Ta is equal to A by C. Okay. Now Tc by 1 minus Tc. This we are getting from Tc plus Ta is equal to 1. So from this expression Ta will be equal to 1 minus Tc. This 1 minus Tc, put it in the denominator, is equal to A by C. Next cross multiplication. Ctc is equal to A into 1 minus Tc. Open up the bracket. Ctc is equal to A minus Atc. Bring this Atc minus towards left side. It becomes plus. So Tc take common out. Tc into A plus C is equal to A. Therefore finally Tc is equal to A by A plus C. Okay. Next. Similarly we will derive Ta also. So below write down similarly. The same what you have written here, you will write here Tc by Ta is equal to A by C. Now in the numerator, instead of Tc, we will write 1 minus Ta. Same students, above we have seen, since Tc plus Ta is equal to 1. So Tc will be equal to 1 minus Ta. Substitute this 1 minus Ta in the place of Tc. 1 minus Ta by Ta equals to A by C. Afterwards what is to be done? Cross multiplication. After cross multiplication, we will get ATA is equal to C into 1 minus TA. Okay. Now next same, open up the brackets. ATA will be equal to C minus CTA. Bring this minus CTA towards left side. So ATA plus CTA will be equals to C. TA is common. Take TA common out. Inside A plus C is equal to C. Therefore, TA will be equal to C by A plus C. Over. This is all about transport numbers, students, which is a very important question and also very easy. Okay, so this is sufficient for your examination point of view, students. Please kindly try to note down in your notebook. I always suggest practice. See, once if you write in your notebook and then take a rough paper and practice 2 or 3 times, it will be very easy. Easily you can remember in your exam also. And whoever is watching for the first time, students, please subscribe the channel. And also who have already subscribed, please like the video and try to share with your friends. Okay, so thank you all, students, for watching. Meet you in the next video with a new topic.